Jane is at Uber, where she works on the many microservices that Uber has deployed. And so yeah, Jane, the mic should be on. Maybe you just want to start off by actually take us through. We end up at Uber, but where were you before Uber? Take me on kind of your journey to microservices.
Sure. I was at the federal government before Uber for a long time. I was a defense contractor primarily for the preceding 10 years leading up to Uber.
So macro services, not microservices. I imagine you had a couple monoliths at the defense contractor. I just feel like I think monolith. Is that a?
Yeah, I think that's fair. Primarily monoliths in terms of process. They would build these enormous things where we had procedural things. It would be like large financial systems where the thing would just go on and on and on for years, and we would just iterate on tweaking these little features of large systems, and it would just never end of just changing little features of systems that were closed source and built by vendors that we had no control over, and we all just felt so helpless. It was terrible. It was frankly terrible.
So were you like, I literally want the polar opposite of this experience? Because it goes from like the federal government to Uber definitely seems like one end of the spectrum to another. Is that a fair?
I got tired of being involved in wars that never ended, actually. And so
literal wars and metaphorical wars, perhaps.
No, just the war part.
Okay, there you go.
And so taxis didn't seem so bad. And then one day they said, "Would you like to come work for us?" And I was like, maybe. That sounds pretty okay. And then I went to go work for them, and I like them a lot.
So tell me about how Uber is different in terms of obviously at the opposite end of the agility spectrum, and how.
Well, this seems like a strange metaphor to use, given I don't want to be involved in wars, but it's like being strapped to a missile, the amount of velocity that you have at Uber. So we stand up new services every single day that 2 or 3 engineers can get together and decide we want to go and build a thing, and they kind of don't even have to ask permission. They just say, we want to go build a thing, and they go and they build it. They open a repository, they commit some code, they stand it up because their manager thought it was a good idea, and they go and they build it.
Okay, so we got a lot to talk about there. So you got 2 or 3 engineers who are kind of gathering around the water cooler or what have you, and they're like, let's go build this thing.
In the kitchen over a snack, they're like, gosh, we need a thing, let's go build it, and they do it.
Okay, and so, and you said, did I hear you correctly that you're deploying new services every day?
Services, plural, every day.
Services, plural, every day. So I want a moment for that to sink in. So like new services, new surface area of the, so that's a lot. Are you, now, when you introduce 2 services, do you have to go get rid of one, or do you have?
Well, we deprecate services too, right? Yeah, so there's churn. So it's not that, the number of services is always increasing. Some of them get turned off and decommissioned. But yeah, we onboard new services every single day.
That's amazing. And so I want to hear a lot about that. I'm kind of reminded of Victor's presentation this morning, where he warned about the anti-pattern of nanoservices. So do you?
No, I have feelings about that.
Okay.
So one of the great things about having lots of tiny little services is it allows you to peek into tiny parts of your infrastructure. So if you have a service whose whole job is to figure out whether your NICs are at full duplex or not, you can figure out whether you're doing that job really well.
Is that an actual example?
That is not an example. But
so can you, and if, I understand, if you can't, can you give an actual example even if you change the nouns?
Let's talk about surcharges on roads or bridges or something. Like if I want to figure out whether we're doing that really well, instead of having something that calculates the whole fare for an entire route, and that's a million lines of code or something, instead of having that whole service performing poorly, I can figure out each individual part of that service because it's broken into, call it 30 or 50 different individual services. And so I can peek into each of those services and figure out how each of those are doing. And instead of them being, thousands or tens of thousands or hundreds of thousands of lines of code, maybe some of them are 500 or 10,000 lines of code, and that is way, way better to me. And I can set up instrumentation for each of those and peek into them and figure out how each of them are doing. And I can also isolate the failure of those. It's way better to me.
To be able to, so because you're kind of blowing up, truly blowing up the app, and now every component of the app is now its own service. do you find you're reaching over the network a lot?
Well,
for that
you're
stuff?
talking about the app, meaning what, the thing on my
Well,
phone?
I mean, the thing that calculates the fare, right? So
Yeah.
instead of being a million lines, it's hitting 50 different service endpoints to calculate the fare,
Well,
say.
sort of. I mean, I'm talking about the back end, right?
Okay.
So the stuff that talks to the app is something
Sure,
totally different.
Sure. But so on because one of the challenges that we've had in our journey to microservices is that some of these things end up being linear, and now you've got various timeouts and so on, and we found that the end-to-end performance was more observable, but often we found that we had to go improve the performance.
Yeah, so the way that we get around that is instead of just failing, we find that people don't like it when you so if Google just gave you no result, that sucks, right? Nobody likes a failure. So what we do is we just carry on and we provide degraded performance. And so if we can't calculate, and let's go back to this pricing example, if we can't calculate a fare or a surcharge or something at the time, we carry on and later on we adjust the fare. And so if something falls over and that tiny little service can't do its job, we say, okay, when we tried to do this, this service wasn't there or was degraded or something, and we keep track of what it should have done if it was there. And then when it comes back later, we replay what it should have done and ask it to do its job.
Wow. And that sounds hard to get right. Is that not?
It is hard to get right.
Right, okay.
That's why we hire bright people.
Oh, right, okay. So I mean, is it fair to say that you're the Bruce Lee with the nunchucks kind of looking for?
Whoa, I'm perhaps an apprentice, and maybe there are bunches of us. I'm not the Bruce Lee.
Right, sure. But because I mean, it requires a lot. I mean, just in terms of wrapping your brain around that whole. Because now you've got a bunch of different microservices.
Yeah.
And yes, you've got kind of 2 or 3 developers per service, but who kind of keeps the end-to-end in their brain, or do you not do that anymore?
Well, so we conduct like architecture reviews constantly, and
Okay.
so with pricing, in fact, I was that person, and so what I would do is go and conduct an end-to-end architecture review of all of pricing. And so this is like a week-long review where I sit down the lead, I guess, programmer for each of these services and say, hey, tell me how your service looks.
Okay.
And have them draw it out on a whiteboard. And frequently they can't do this. And so you have to ask them hard questions and say, show me what all of your things talk to. And then compose this in an actual flow chart. And if it doesn't make sense, go back to them and have them do it again. And then once you've got this, try and connect all of those pieces in a larger flow chart, and then present this up to sort of like C-level people, and then have them say, this doesn't really make sense. Go back down to those programmer people and make them have it actually make sense.
Okay.
And then when you've got this done, that creates like a task flow, right? And so you wind up having this whole process itself generate a parallel task flow to actual development, which is get the architecture right.
Right.
So, but understand that this is just for pricing. You've also got like a mapping group, you've got a data science group and a machine learning group, and they're all doing this too. So the problem is that if you were trying to do this from like the very highest like Uber perspective, I don't think anybody could. It's very nearly impossible. If you were to try and keep all of that state in your head, you would have to have terabytes and terabytes and terabytes of state in your head, and like our computers can't do that.
So it sounds like, I mean, for you, the microservices approach is almost about inverting the way you architect, and it's almost like bottoms-up architecture in that
or if you want to talk about it, I think it's more like outside in.
Okay.
Right.
So what do you mean by outside in?
Well, so it's really funny. This idea of pre-Copernican of the container in the middle, I really like that idea.
Yeah. What do you think about it? I thought that was good.
So, I look at orchestration of, we do orchestration from the outside. We try and look at just organizing everything from the outside, and we cannot peer into the tiniest little services and ask them if they're healthy. We just can't. We expect services to give us some kind of indicator. Are you healthy? Because I don't know how you work. You might be a Haskell service for all I know. Like, just give me an endpoint that I can ask you if you're some kind of healthy, and I expect you to give me like a, I'm a healthy-ish, right? And we sort of...
Are you using Haskell for rhetorical flourish, or do you actually deploy Haskell in production?
Gosh, I hope we're not using Haskell, but I wouldn't...
No, that's why I'm asking.
But I wouldn't know. That's the thing. I consider containers to largely be black boxes in which developers put code,
right.
And I expect it to behave and give me like a red, yellow, green.
And so how do you deal with it? And these are all HTTP services, I assume?
And Thrift.
And Thrift, okay. I just threw up in my mouth a little bit, but I saw it.
Yeah, me too. But look, I don't have...
No, I'm good. I'm moving on. I wanted to let you know why I went.
Containers let me not care.
A little bit, right, sure. Containers let someone else care, I guess. So, yeah, right, it makes someone else's problem. I mean, there's still misery in the world, though. For the HTTP-based services, how do these services define their interface? I mean, do they, how do you,
because
this
you're
is
going to make me sad. We have a thing
that's my goal, actually. You were way too happy about all this stuff working, so I got to actually,
do you know
the sadness has to be there.
Have
I'm
you
just
heard
going
of
to
a
dig
thing
until we get
called
there.
Clusto?
What's that?
Have you heard of a thing called Clusto?
Clusto.
Yeah, me neither. There's
Like, wait, Clusto? Like,
Yeah,
is this a villain in some sort of? It's like a.
It's a villain.
This is like
There's
a
a-
services architecture
No,
villain.
there-
That it's like,
it's,
oh God, Clusto, run!
There's a piece of software that was written at Dig. Do you remember Dig? It's like Reddit Lite, kind of.
You mean Dig, the one with
DIG.
two or three G's?
Some number of G's.
Some number of G's, right?
Right.
Exactly.
And we inherited it from a guy that no longer works for us.
Oh,
and
the guy that no longer works for us.
He's a good guy.
Yeah, he's a good guy. He's always a good guy. Give him my best. But guy, if I see him, I'm gonna.
And it was like a JSON store directory, and then people added lots of stuff when they figured out it was JSON, and so like they're JSON blobs describing everything. And then one day I said, hey, do you know this looks like Active Directory? And somebody said, never say that again.
Right. I will thank you to compliment the emperor on his finery, and never again.
So that's where we store metadata.
Okay.
In this huge directory that was initially something that was kind of just to store hardware asset information.
Oh, interesting. Okay.
And now includes like exposed ports and stuff like this. So we have a lot of configuration data that is in a very Uber-specific database that lives kind of in all of our data centers.
And does that database, does that metadata describe the actual interface for the service as well, in terms of like, so that well, at least it's written down somewhere. I mean, it's like I think it's, because I think it's one of the challenges of microservices, frankly, is that
it's challenging.
That you do have this important metadata associated with the service, because it is so, I mean, with HTTP and with JSON, it's obviously so loose what you can go do.
Well, yeah.
That it requires us to be much more rigorous about how we write that stuff down. So, all right, so each service says, here's what I take effectively as inputs, here's what I have as outputs.
Mostly.
And then does Clusto, I just love, is it, and it's CLUSTO, right?
With two G's.
With two G's, right. And does this validate that the service actually does what it says it did? No, of course, yeah, no, okay. Because it's like, it's for asset tracking, like why would it know to do that? Right, yeah, right.
That would be useful.
Yeah, right, this is like we were doing, the joyent back in the day was doing billing with a blogging platform. You're like,
Makes
what?
sense to me.
Is this like an IT Mad Lib?
It's open source, you can just extend it.
Right, I guess so, right, okay. Makes no sense. Okay, so how about state? How do we deal with, everyone loves to be like, oh, stateless, stateless,
state
stateless.
sucks, man.
State sucks.
We kind of demand everybody be stateless, and so what they do
No,
is...
wait a minute, does that actually work? Does this demand
Yeah, mostly. Well, so...
Yeah, that's right.
Yeah, mostly.
Right,
Yeah,
yes, asterisk.
So, well, we never reboot anything, kind of. But we do lots of failovers, and so almost everybody has a Redis. And so we keep state in Redises, and
and that Redis is persistent.
Well, Redises aren't persistent, because if a machine falls over or we fail over a data center or something like that, and this happens, you lose your Redis. Like, you can't have that. And so we keep state in Redis, but the thing is, the way Uber operates, when you're on a trip, like that state has to be kept, right? But when you're not on a trip, I don't care. You're in a database on a disk somewhere. And so generally, we have this data that has to be kept in memory at all times, and everything else is not kept in, is not stateful. So most of our services are pretty stateless, and then we have stuff that isn't stateful. So in terms of keeping state, we have kind of clever ways of getting around things being failed over that I can't really talk about publicly, but generally all of our services are stateful, and that's how we get around stateless rather, and that's how we get around these problems. But most of our services operate in very large clusters of in-memory state
Okay, and they're either gossiping, they're doing some things to get to rough consensus.
And if you tip them over, and some of these are enormous clusters, if you tip them over, it takes a few minutes for them to sort of refigure out state, but a few minutes is like 5 to 10 minutes, and then they're good.
And then that state is, that in-memory state, it sounds like it's non-transactional state. It sounds like you've got other stores that are actually keeping track of transactional state, or?
Well, transactions meaning what?
In terms of like, Uber you need to be sure you're only billing people once and so on. I mean, you do have.
Well, but billing is like when you close out a trip, right?
Okay. And then, so that transaction, does that happen, is that being, I mean, or just say more generally, do you have any state that is traditional, in kind of a traditional SQL kind of store?
Well, not really. Most of our state is like, this user is on a trip, which is important. And the other thing is, where are all of the hosts that I need to talk to right now? And that you can pick up by, like you say, gossiping among your peers.
And is that, so for the kind of the Redis state, the kind of the local state, I mean, because Redis can be made persistent. I mean, it's got a.
Kind of.
Right, kind of, right. Kind of in that, like, it's terrible and no one should use it. But there is actually, you should only use Redis as an in-memory store.
Or to avoid meetings.
Or to avoid meetings.
Yeah, so if you have a service written by 3 developers over there that you don't like so much,
yes,
because their service is unreliable, what you do is you put a Redis between you and those developers, because if their service falls over, you can sort of cache results from their service, so that you don't have to have meetings with them to talk about how their service is unreliable.
But I thought I hated meetings. That is taking hatred of meetings to a whole new level. Like
we have numerous Redises whose whole purpose in life is to avoid those meetings.
Like I will cache you. If you don't stop being an asshole, I will cache you and never talk to you again.
All the time. We have services who are unreliable, and their teams refuse to make their services more reliable.
That's it. I'm caching you. I don't care if it's inconsistent. How do you deal with that? I mean, so fine, you're caching now this.
The degree to which it is latent or inconsistent, we figure out whether that is acceptable or not. And if it's unacceptable, you have to have a sad meeting. And if it is acceptable, okay.
Interesting. Okay, so you basically you're going to accept the inconsistency for availability. I mean, in terms of cap trade-offs, you're building an AP system, which is well and good. And so especially when those things don't require that kind of consistency, that works out well. So then how do you prevent are you concerned about that state then becoming canonical, being like, wow, actually I could just go to why go there at all? I mean, I don't even have to blow off their meeting if I can just go to your Redis state and get it from you. I mean, do you find that you end up with...
well, because you do actually check to see if it's there. And if it's there, it's authoritative. And if it's not, you check your Redis.
Okay, but are you worried about then your Redis becoming authoritative for someone else? Are you worried about kind of sleeper cells of data terrorism inside of Uber?
Gosh, now I am.
Okay, I don't know. I mean, it's just like it seems like Uber has managed to pull off the dream of no centralized authority, and yet you're not like Somalia, or doesn't sound like it.
People ask me this a lot. They say, well, is anybody watching this whole system? And the problem is, I explain this all the time. I say, if you were to take this entire system and describe it today, tomorrow it would be out of date, and the person who had done all that work to describe it would have wasted it. And kind of the beauty of this system is you could, if you describe it as a huge net, you could cut out an entire piece of it and the rest of it would keep working. It's kind of like the ARPANET vision, right? The thing is, it works pretty well, and so I'm hesitant to try and take somebody and put them at the top and say, your job is to be responsible for all of it if it continues to keep working this way. And maybe as we grow bigger and we get to 20,000 engineers or something, we will have to get there. But how would you be responsible for describing 20,000 microservices? I'm not sure you could.
Yeah, no, it's amazing that it works at all. I mean, that you're able to.
Yeah, it is.
I mean, so do you find that that microservices has? I mean, surely it sounds like it's made it much easier to scale organizationally scale. I mean,
we couldn't do it without them.
Interesting.
Yeah, if you tried to do this with some number of large monoliths, it wouldn't work.
So what have been the biggest challenges? Clearly this has been...
Organizationally, it's the problem. We found that initially we had this great increase in velocity from tearing down. So for background, we had 500,000 lines of Python was driving the back end of Uber. and every time it tipped over, we had an outage, and nobody could use the app. And so this was a problem. We broke it down into these microservices. And so doing that gave us all this velocity, which is great. The problem is then nobody was watching the overall architecture of where things were going. But that meant that you had to have pretty good managers who were watching where everything was going. And so, but sharp managers are hard to find, just like sharp engineers are hard to find. And so the organizational problem is really difficult. And that is the biggest drawback that we find, that you have to have people that are watching not just their group of people, but they have to sort of socially know who to talk to. They have to know who's working on what in which office, and they have to know where there's overlap so that there isn't contention.
Although that was always true with the monolith too, right? I mean, the monolith, you had the same issue of, if we are all going to architect one monolithic thing.
But you did have somebody who owned that monolith. You did have somebody whose job it was to own the API. You did have, a PM for that or a director of that. And now you have all these pools of people that are responsible for their own, thing. And now we don't really have that.
And so, just being able to get people who can kind of wrap their brains around the complexity.
Yeah, we have tons of cowboys, and we have no chiefs, or some analogy to describe that.
Yeah, I mean, it does sound like, it sounds like the Wild Wild West, actually. I mean,
kind of.
But it sounds like, it sounds like it's also yielded tangible results for Uber. So it sounds like it's working at the.
We seem to be doing okay.
At the most macro levels. So tell me about how containers play a role in this. I mean, do microservices tend to live in containers, or how have you guys done that?
We have a mandate that nobody is standing up a service that is not in a container unless you have just ludicrous needs for hardware. So everything standing up today is in a container. And one of the things personally that I like as kind of an old school sysadmin is this forces devs to understand that they don't get like file I/O. I really like that they just can't say, I need, etc fax.dfoo. Like, no, be responsible. And so this has taught our developers to be a little bit more mature. And also, once we get people in containers, they're really agnostic about the platform. And if something comes along later that is a different platform, I can move them to that with little effort. So for me, as somebody who is, or I guess was responsible for all of this stuff, that's a really big win for us. I really like that.
So even if you are deploying, because we had one customer that was embarrassed about the fact they were deploying one container. They're not only deploying containers and VMs, but they were deploying, which admittedly does make me weep a little bit, but they were deploying one container per VM. And I actually think that there's better that, I think, than the alternative, because there at least you have that decoupling that you can, in the future, you can begin to move things to different infrastructure. It sounds like you guys have.
I don't care. It's a teaching tool, number one. If you teach someone to work within Docker or any kind of container, you have taught that developer how to develop a certain way, which many developers who are accustomed to owning the whole box are not familiar with. And that's a very big step.
So, and how have you helped people on that learning curve? So there's a learning curve in terms of
we have a really thorough education program at Uber. We force them to go through this and learn how to do it.
Oh, interesting.
Yeah, we bring people in who have never used Docker, and we, have them sit through classes. You're going to learn how to do this.
And so before I just kind of am dropped into Mogadishu with my Kalishnikov, I actually am. It sounds like I do. How long does that training last? How does that work? That's kind of.
Well, you get a week when you start.
Okay.
And then after that, there's an hour-long class on just containers, and if that doesn't take, we can send you back. And if your service doesn't work.
Now I actually feel like I've walked into an episode of Silicon Valley. You actually have people that need to be re-educated that are really like, I can't believe I got to do this. I got to send you back to container school.
I don't know that we call it re-education.
Okay, right. And then has that been, is that also an opportunity to kind of, do new developers feel overwhelmed, empowered, a little of both? How do they?
Some of them feel a bit overwhelmed, but they're also coming into Uber, which is overwhelming generally. I think the overall experience with our education program is pretty good, but it's intense. Our environment, we write just about everything ourselves, and so it's really new. The thing I wanted to say is that before we got to Docker, we had our own kind of Mickey Mouse container architecture. And so devs were learning that, and we migrated from that to Docker, and then now we're doing our own kind of Mesos thing. And so migration from one kind of container platform to another kind of container platform to anything else is actually pretty easy if you're familiar with it.
Okay, so bigger deal to go from non-containers to containers than move from one container platform to another.
Absolutely.
And then so on that note, I mean, you got a lot of people in the room who are who are starting the journey,
Yeah.
I would say. I think it's a fair statement, or have begun to dip their toe in the water. Given all that you know now, what would you advise folks who are trying to move from a monolith to a microservices container-based architecture?
So if you're a dev, find the Kool-Aid and drink all of it. If you're an, no, I'm dead serious. If you're an ops person, get better, like get better.
So what does get better? I kind of feel like my son is a baseball player, and I kind of feel like this is like, he has told me, like, Dad, never tell me to throw strikes. So it's like, obviously, I'm trying to throw strikes. What does get better mean when?
So the thing is, you need to learn how to manage these things. You need to understand, like, how to change your system settings to understand, like, the max memory per process. And gosh,
So you've got, if you're an ops, you've got to be prepared to go deeper, it sounds like. You've got to be prepared to, like...
you need to be able to tune the system settings on a box, and many people actually can't go in and do these things because they expect to have a web interface and a GUI for these things, and you need to have a thorough systems understanding of these boxes.
Right.
And you know, like, they want the web console for like an Amazon provider, and that's not going to help you.
That's not gonna, right, okay. So be prepared to go deeper. All right, so sorry, that was number 2. So if you're devs, find the Kool-Aid and drink it.
And hire SREs.
And hire SREs.
Yeah, and then, you know, I think if you've got all of these things together, you will have a pretty successful container infrastructure going forward. But I don't think you can expect to do containers without these 3 things.
That's great. Okay, cool. Any questions for Jane? I mean, there obviously, Ryan is telling me no questions. Okay. Yes, one question. Sorry, Ryan.
Just one?
Yes.
Okay. I'm really curious about how you manage and build this infrastructure model. It seems like you're kind of designing it on the side, and then have specific jobs for everybody to do, and then when you get a desired result, then you move to a next management. Am I making sense?
No. We're building the spaceship as we're flying it.
Yeah, it's design and build.
Yeah, a year ago our infrastructure was totally different. We didn't even have, like, we had 1 data center instead of 4. I have no idea what our infrastructure will look like in a year, software or hardware.
So, yeah, there you go. Yeah, it's a design and build. So great stuff.
I'll be around if you want.
Yeah,
to
so
later.
Jane will be around, because and we will have an extended lunch break. So Jane, thank you very, very much. Really interesting stuff.